In the lesson 4.6 example, are there many old college students? We're going to look at what happens when you lack independence. Government data shows that 8% of adults are full-time college students and 30% of adults are age 55 or older. We want to know that if we randomly select an adult, is the probability that they're both of those two things, a full-time college student and over 55, is that the same as the product of the probabilities of the individual events themselves? 8% are college students, 30% are over 55. If I multiply those two, I get 0.024. Is it true that 2.4% of the population is both of these two things? Why or why not? So what we need to look for is this multiplication rule is specifically for independent events. And we need to know what independent events means. Independent means that knowing if a person is a college student, does that give us any additional information about them being 55 or older? So let's just think about that for a minute. Being a full-time college student and being over 55 are not independent because most full-time college students are recent high school graduates. That means they're usually in their late teens or early 20s. Now, it's possible that there are some full-time college students that are age 55 and older, but we're saying that most of the full-time college students are young. Knowing that a person is a full-time college student makes it more likely that they're young, less likely that they're older. Since the events are not independent, we can't use this multiplication rule to find the probability of both events. So we cannot use this to find the probability that someone is both a full-time college student and over the age of 55. The probability that they're both of those two things is probably not 0.024. If you'd like to try a problem like this in your textbook, you can try exercise 9 in this section.